Welcome to the Math Workshop. This is Megan. In this video, we will explore the math routine of same and different. This math routine can be used with students of all ages. And we've done the hard work for you. We've created over 200 different unique slides that you can use with your K through 6 students. We will share the link to learn more about where to purchase this awesome slide deck in the notes section for this video. These are the other math routines where we have done the hard work for you. We have hundreds and hundreds of colorful, engaging Google Slides with rich mathematical ideas to entice your mathematicians to further their thinking, along with free videos on how to facilitate each of these math routines. You can check them out at our website, themathworkshop.net, to learn more. So we have array images, quick images, visual patterns, tell me all you can, which does not belong, and this video, same and different. These are the other math routines that we will be adding to our math toolbox soon. Number talks, so look for those, counting around the room, and guess the rule. So math routines promote student thinking, reasoning, and sense making. They strengthen your mathematical community and further students' understanding of math concepts, thus increasing their individual agency as confident, capable mathematicians. Here are tips for facilitating the math routine of same and different. You could use this math routine as a warm-up or an exit ticket for math class. Just like all the other math routines that we've been sharing, you really want to keep it short and sweet. So you want to do it daily, really 5 to 10 minutes. So short and sweet. The role of the teacher is the same in all of these math routines. Our role is to ask, listen, and learn about our students and their thinking. You can use talk moves, which we'll look at on the next slide, to help facilitate the discussion amongst your students. Give students the gift of silence before taking any comments. Really honor that wait time. I know that we all process and think at different rates. I know that I can be a slow thinker, so it doesn't mean I'm not thinking good thoughts. It just means I need a little more time. So a lot of your students are going to be the same. And students could fill in a Venn diagram if you wanted to use along with this routine. So you'll see how that would help with the comparisons in just a minute when we get into it. Here are those talk moves that we love. I know the poster says math talk moves, but really we can use them throughout our day of facilitating discussions amongst our students. So that revoicing, and that can be from the teacher or from other students. That's oh, so you're saying that, blah, blah, blah. That repeating, I always remember that the repeating is an invitation, and it's an invitation to hover over a really interesting idea. So it's the teacher's choice. The teacher would say, oh, I'm thinking in my brain, oh, Jose shared a really cool thought. So I might throw in who heard what Jose said and can repeat it. So it's an invitation. And if no one heard what Jose said, and sometimes that happens, I'll say, oh, Jose, that was just really interesting. Can you repeat that? And then let me ask again who heard it. And then usually there's always lots of hands that go up because usually most classes have students that want to talk and want to share. But then the other second part of repeating is I always want to go back to that first student and say, is that what you said? Once that other kid repeated, because sometimes students don't repeat what the child said. And the purpose of repeating is to hear that idea again. So I help model with students that if the student said something different. And I say, oh, and Jose might have said, no, that's not what I said, Mrs. Brewer. I said this. And so we give that other child another shot. So it's not a punitive thing. It's just trying to really implement that mathematical habit of really listening to each other, because I believe my students can learn a lot, probably more from each other than just from me, the one teacher. So I'm using these kinds of talk moves to facilitate that to happen. Then there's reasoning. That could be, do you agree with, do you disagree with? Also, reasoning could be, how do you know, why? Then there's that adding on. I love that one. I try to remember to do that. And it's so cool how, again, if a student shares something really intriguing, all you have to throw in as the teacher is, ooh, who can add on to that? And it always blows my mind, from sixth graders down to kindergartners, that often students have something they're like, oh, I would like to add on this. It's really cool. Then, of course, that wait time after we ask a question, allowing think time. And I always try to set my kids up for success and say, well, I'm going to ask a question in just a moment, but I want you to keep your thoughts in your head. And maybe I'll do some signal like, this means I'm thinking, or something. And then I'll let them know, okay, now let's start our discussion. Because and again, I explain to students there's nothing wrong with telling them we all think at different speeds for different questions. So, it's not all that we're all going to be thinking along the same way, same rate. So let's honor all of our think times for each question. And then that great turn and talk, that elbow partner or shoulder partner, sharing. So first you got to have time to think, that gift of silence, but then you can do a turn and talk once I've had a little time to think about what I should say when we turn and talk. That's such a great facilitation strategy. So look at all the content that we covered in our same and different Google Slides. We covered number and operations with base 10. We covered number and operations with fractions and decimals, geometry, measurement, data, and statistics. And remember, this is K through 6. So that's why we have over 200 slides. And we divided up our slides into categories. So first we have models, then we have numbers, and then we have equations. And we really recommend you start with models, because those are pictures and they tend to really open up the mathematics for all students. Models tend to really be presented in that conceptual understanding and supporting conceptual understanding, whereas numbers and equations are more abstract. So it just really, the models can lay a foundation to bridge that conceptual learning with the procedural understanding, which is numbers and equations. All right, so let's look at some of the models. And I want you to know that in the models, we put mostly kindergarten examples first, and then first grade, second grade, and so on. And it just kind of moves up through the content up to sixth grade. But I want you to know you can feel free, no matter what grade you're teaching, to jump in anywhere. And that's why we're not putting out there like, here's same and different routines for kindergarten, or here's another package for third grade. We're putting them all together. So you can differentiate. If you have days where you're able to take a small guided math group, and maybe these are some kids that would benefit from some thinking that was in some previous years' standards in mathematics, use some of the slides that would support their thinking there. If you've got a group of students that are ready to be challenged and ready to explore some mathematics that's maybe coming up in the next year, move up in your slides. Feel free to move around. So that's why I wanted you to understand how we scaffolded the examples. So the questions are always going to stay the same. The questions are really simple, and they're in the name, same and different. What's the same and what's different? That's all we're asking, but they're so open-ended. They're really amazing. So I want you to know the first couple examples I'm going to show you right now really don't have anything to do with math. And the reason is purposeful, that we wanted students just to get familiar with this routine first before putting in the math content. So feel free, these are images I think that I've worked with K through sixth grade. I think all kids are going to like the images and they're appropriate for all. So I just wanted you to know that. They look a little different than the math examples. So here's one. And this is a non-math example again. You simply display the image, ask kids to have the gift of silence and considering what is the same about these two pictures and what's different. And this is not a teaching moment, honestly. You know, we have the rest of math class that there might be teaching moments. This is really to see what do we get from our students. We're really going to learn a lot. Remember, we're asking, we're listening, and we're learning. So some examples of what students might say. Oh, these are both animals. That's something that's the same. These are pets. That's the same. They're both outside. That's the same. Well, what's different? One of the animals has its mouth open. What's different? They're different animals. One's a cat and one's a dog. So, you know, we're just kind of getting used to the routine, and there's lots of different possible solution or answers your students are going to give you. Here's another example, again, non-math. So, you know, they're both for transportation. They both happen to be yellow. They both have wheels. What's different? Probably only one kid can fit on the bike, maybe two. They really squeezed. I don't know, that might not be safe. The bus obviously can hold more, you know, so your kids are going to come up with different things that they're going to tell you. Again, this is a non-math example. Here's another one. They're both balls. One, you know, they're going to come up with different things. One's for dribbling, one's for shooting, one you use your foot, maybe your head, one you're using your hands. The other one you're not supposed to use your hands, I guess, unless you're the goalie. So again, a non-example. Here's another non-math example. All right, and I had one more. We have one more in here. Okay, now, so those were just to warm kids up. And remember, you're really going to want to just do one math routine a day because we're keeping it short and sweet. And if you're using that gift of silence and you're giving kids opportunity to turn and talk, and then maybe you briefly have a whole group discussion, then your time is past. Okay, so now let's get into the math examples. All right. So again, we're starting with kindergarten, and these are kindergarten math positional words that are in the standards. And so think about what those kindergartners might say about how above and below are the same and different. And again, there's nothing wrong with using this in other grades. Especially, you're going to see there's a lot of strong vocabulary support within these slides. So if you have students who have been struggling in mathematics, or maybe you have students that are English language learners and are acquiring a second or a third language of English, these slides can really be supportive. Let's look at another one. Still, we're in kindergarten, hoping that the students see the difference between solids and flats and how they're the same, how they're different. Here's another one with geometry. So there we have an example of a solid on the top and a flat shape on the bottom. And now look at the vocabulary. We've got the name for the students. You're not always going to see vocabulary, but sometimes you will. And also have some attributes with sides and vertices. Another one. Now we're really wanting kids to think about the difference between a side and a vertice. What's the same? They're both attributes of shapes. What's different? It's different what they're looking at. Where is it, a corner? Is it the side of it? All right, now let's look at, we've got so many different models. Here's an example of using the 10 frame and a 5 frame. What's the same about them? Well, they're both filled. And again, if I was a teacher facilitating this, I wouldn't be sharing these thoughts. I'm just sharing them with you, that what students might tell us. So they're both filled frames. They both have 5 in a row. What's different? Obviously, the 10 frame has 2 sets of 5. All right. And we're also going to have some dot images, having students really think about the same and different. Some more 10 frame examples, but here we've got base 10 blocks on the top. So those are both representing 20, just for your information, but in different models. So we're having kids make connections. Then we've got the Rec and Rec tool. This is a hands-on tool that sometimes teachers get, especially kindergarten teachers, get a big class model set for demonstration purposes and then get small models for students to use. It has 20 beads if you're not familiar with it. And what's so wonderful about it, the colors don't matter. It doesn't have to be red and white, but it is important that you have 2 colors, whatever the 2 colors are. And the important part is that the 5 and the 5 on the left are the same color. So you can just visually, you just see that very clearly that that's 10, 5, and 5. And then the other set of beads are just a different color. So it's easy for that visual discrimination of decomposing numbers up to 20. Some more 10 framework. Here we're really wanting students to focus in on the missing part. That helps us to know how many there are by looking at what's missing. Here we have some really great examples of the 100 chart. So this is a 100 grid. It does not have the numbers in it intentionally. So it would be helpful for students to have some examples of having worked with a 100 chart or a 100 grid, but they don't have to. But you might want to, if you're going to use this slide, if they haven't had any examples, explain to them it is 100. They could probably figure it out. I know it's part of it's shaded. That's intentional because we want them to think about what's the shaded part. You can look at it either way. It doesn't matter, but you need to decide, do you want kids to focus on the shaded part or the unshaded part? This example is really easy because it's 50 and 50, shaded, unshaded, but other examples that you'll see in the slides are not half and half. So you just decide, which one do you want them to focus on and what's the same and what's different. So more vocabulary. We know in after kindergarten, there are standards in first and second grade about, it's actually beginning fraction standards, about students being able to cut up circles and rectangles in halves, thirds, and fourths. So we're getting ready to use that language and quarters as well. So you'll see slides that support that mathematics. Now, we also know in second grade, there's a standard related to it's getting ready for multiplication, and it's dealing with this vocabulary of columns and rows, and it's in relationship with arrays. So that in second grade, students are looking at repeated addition. It could be 5 plus 5 plus 5, 5 plus 5 plus 5 equals 15. And that is to build into what they're going to do in third grade, knowing that 3 sets of 5 is 15. So that you can hear how knowing the vocabulary of columns and rows can be really essential to understanding that array model. Here we've got those linking cubes. This slide is really, the purpose is to deal with even and odd numbers. That standard about students understanding that even numbers have partners or pairs, odd numbers do not. So seeing if students make that understanding, make that leap to it. You're also going to see a lot of examples with number lines. So first you'll see examples with whole numbers and number lines. Here we're counting by tens and counting by fives. What is the same about these? What's different? They both start at 0. For these particular examples, they both end with 100. But of course, counting by fives, we see a lot more numbers than counting by tens. You're also going to see measurement standards. So here we are noticing a difference between an o'clock and a 30. You're also going to see within measurements some money work. So I really like these examples because the grid represents, it's got the number of units that are going to be in the cents. So for example, on this slide we're looking at, we have 25 and 25 for our quarters. And we have that 50 piece, that $50 piece, 50-cent piece. And it's showing, I love this because it's showing visually that 25 and 25 is the same, takes up the same area as 50. All right, so more money. Here's another. Oh, still in measurement. We've got inches on the top and we have centimeters on the bottom. So we can have a discussion, facilitated discussion with students about what's the same. Those are both standard units that are used to measure, but they're different units. So we've got US customary on top, and of course we have metric on bottom. And here we have tools for measuring. So we've got measuring weight on the bottom, or mass, and on the top, temperature tool, thermometer. Got some patterns. We have that repeating pattern on the top. We have a growing pattern on the bottom. You're going to see place value work. You're going to see more number lines. This one has to do with greater than and less than. Modeling that. We're going to be using pattern blocks. This one could be, if students were ready, they could look at, this could be dealing with fractions. If they're not in fractions yet, they could simply see that they're both trapezoids. If they've used these pattern blocks, they know that the red one is just the trapezoid, but the green one, those are 3 green triangles that make up a trapezoid if you put them in that arrangement. We're going to have lots of different fraction representations and models because we know fractions can be so abstract, but when we can see a model, it can really support our thinking. So different, here we've got 1/5 and 2/10. They are equivalent, but that's hard to see because our wholes are different. So you can have a rich discussion there. Here we have 4/5 and 9/10, so they're both one part away from a whole. See if your students recognize that. If not, I'm sure they're going to recognize lots of other great things. Here we have the top fraction has one more than a whole, and the bottom fraction has one less than a whole. So you can see there's a lot of intentionality that went into all of our slides. Here we have that number line model for fractions, which shows up in grade 3. Very, very important. So we've got lots of different number line examples for fractions to support students' thinking. We even have negative numbers for those 6th graders. Here, some examples with the area model. There's 6 on both. We have 1 times 6 on the top is 6, and 2 times 3 is 6 on the bottom. Here we have an area model with items, cupcakes, and I think those are tomatoes. So what's the same, what's different? Here we have some square number examples. And here we have the number line and a word problem demonstrating multiplication. We're going to have some division work. So there's a number line modeling a division problem. It's actually the same problem. And a word problem on the bottom that has to do with division. Here we have multiplication, but in two different ways. So an array and an area model. And the orientation is flipped. So on the top, we see, depending on how you look at it, but we could see 3 columns of 5. And on the bottom, if we're looking at the columns, we see 5 columns of 3. Here we have examples of area and perimeter on the bottom. So area on the top, those square units, and perimeter on the bottom. Here we have, I love this visual, distributive property for multiplication. So we've got the straight multiplication model on the left, and then we redistribute it to see the two groups within. So thinking about, what is this one? 3 times 1, 2, 3, 4, 5, 6, 7, 8. 3 times 8. 3 columns of 8 is 24. That's for the first picture. And over here we have 3 columns first of 4 and 3 columns of 4. And that's 12 and 12, which is 24. We have some time interval work to think about. So the start time, the end time, and then we have this number line model showing how we can solve time interval problems. So what's the same about these examples? What's different? We've got these great vocabulary all up in 5th grade. About line segment, point, the different types of line, perpendicular, parallel. We've got some operating with fractions, got subtraction and addition, modeling it, what's the same. We hear you, Lily. That was the cat. Sorry about that. We've got greatest common factor, least common multiple, what's the same, what's different. So you can see how we're getting up into 6th grade, multiplying fraction by a whole number, dividing a fraction. Oh, I'm sorry. And then multiplying a fraction by a whole number on the bottom too. I know we do have division ones too. Oh, we've got examples with mean, mode, median, and different types of data representations. Those words, reflection, rotation, translation, or different kinds of data. We've got our coordinates, their coordinate grid. Here we have multiplying fractions into the visual model. How are those two examples the same? How are they different? So here are the two factors in the fraction problem, and here's the product. And we're almost finished. I'll let you out in a minute. Here we have operating with negative numbers, integers, more of that. Here we have ratio and proportion problems and variables. All right. Ooh, that was a lot for models. So we're going to wrap up with numbers. You're going to see, again, we're going to start down in kindergarten. You're going to see, so we had whole numbers. There's a whole bunch of different whole numbers. You're also going to see fraction work. You're going to see decimals. You're going to see, again, those integers and exponents, square numbers. With equations, you're also going to see, again, we're going to start down in kindergarten and go up to 6th grade. You're going to see addition, subtraction, you're going to see multiplication, division with whole numbers, with fractions, with decimals, and with integers. Okay, so we made it through. That was a sampling of the over 200 slides we have in our slide deck. So hopefully that gives you an idea of what you could do with what's the same, what's different. Our hope is that you found this video helpful. Feel free to check out our website for other resources to support you and your mathematicians. And we thank you for your time, and we hope you have a great week. Thanks, everyone.